Good morning, everyone. So in today's talk, originally I want to give a report on our discovery of a massive city galaxy at redshift 1.1. However, I think it would be much better to let everybody know some related works before I report this high redshift city galaxy. Therefore, my current talk includes 3 parts. I will show you the structural properties of nearby brightest cluster galaxies and the importance of major dry murders in the buildup of their stellar mass. Finally, I will report the discovery of a massive city galaxy and its implications. Okay, first, let's review some background together. Here I show you example BCG in a nearby cluster which has been classified as a city galaxy. Generally, the BCGs are the most massive and luminous galaxy in the nearby universe. They are usually located close to the centers of the clusters. They are dominated by old stellar population without predominant ongoing star formation. Some BCGs has been classified as city galaxy by excess light from the diurnocular profiles at the large radius. About the formation mechanism of BCG and city galaxy, there are several mechanisms in the early studies, including galactic cannibalism, tidal strippings, cooling flow, and so on. But no one can explain observational properties very well. Recent semi-analytic models and simulations provide a two-phase process. An initial collapse with rapid cooling and star formation at high redshift is followed by late growth via dry murders. These studies also present that today's BCG have built up half of their stellar mass at redshift 1. Importantly, minor murders can be responsible for their late mass growth from redshift 1 to the present. But in this talk, I will show you this is not correct totally. I will show you direct observational evidence that major murder do play an important role during their late evolution. Very recently, Lepot et al. Simulation shows that BCG may enter the dry murder phase at epochs earlier than redshift 1, but there is no observational evidence to date. In this talk, I will also give some evidence to support this. We have known early works identify city galaxies by excess light from the diurnoculars at large radius. But how a light profile deviates from diurnoculars is usually judgment by eye, so which is objective and model dependent. In this part, I will show you a new objective method. These galaxies are 3 typical examples of nearby galaxies in my early paper in 2008. From left to the right, galaxies with almost no halo with extended halos. The second panels are their light profiles in Sloan G and R band, and the best fitting statistical model. Brough et al. In their early paper showed that significant signature of a plateau of the Peterson eta profiles of galaxies with extended halos. We further investigate the profiles of gradients of Peterson eta profiles. We call that as gamma profiles. You can see it's clear that galaxies with the more significant deviations from the model profiles at the large radius tend to have the deeper valley features in their gamma profiles. Therefore, we can use this parameter as an indicator of how a light profile deviates from a model profile at large radius. We found that this parameter is correlated with galaxies' properties. Left panel is the transitional radius from inner component to the outer halo, the luminosity and the size. Statistically, these correlations demonstrated that the more luminous and the large BCDs tend to have more extended stellar halos, and they are more likely to be classified CD galaxies. In the second part of my talk, I will show you the importance of major dry murders in the build-up of their stellar mass from the redshift 1 to the 0. Our nearby sample is identified in a well-selected sample from SDSS C4 cluster catalog. We developed a new photometric method to identify interaction signatures in murders. We finally found 18 pairs or triples emerging out of 515 objects. Here are some examples of nearby murders. You can see the merging signatures are very clear. Were broad plumes in the outskirts and short titles and bridges. So they are real merging systems. Our intermediate redshift sample is selected in an X-ray cluster catalog in the Cosmos field. We identified the murders in the same way as the identification of nearby murders. We found 4 pairs or triples emerging out of 28 objects. These are 4 intermediate redshift murders. The high redshift sample is from Liedman et al. Recent paper. They claims 3 of 14 BCDs in their sample are likely to experience a major murder with 0.6 gigayear from spectroscopy information. Red boxes mark 2 of them. I couldn't find the imaging for another murder in their paper. Okay, now we can investigate the evolution of major murder fraction and major murder rate from the redshift 1 to the 0. You can see both major murder fraction and major murder rate in BCGs increase with increasing redshift. If assuming half of the stellar mass are added to the central galaxies by murder, we estimate that about 1/3 of today's BCG are built up via major murders. If the current simulations is right, today's BCG have built up half of their stellar mass at redshift 1, which indicates that major dry murders would play a more important role than minor murders. We also found the connections between major dry murders and outer city halo formation. You can see the outskirts of these major dry murders have the similar light profiles to city halos of nearby city galaxies. Also the same for the intermediate redshift merging systems. So we conclude that city halos in BCGs are from major dry murders, and they appear shortly after merging takes place. In the last part, I will give a report on our discovery of a high redshift city galaxy in the HUDF region of good south field. This figure shows the location of these high redshift city galaxies in the entire good south field. We identified this high redshift city galaxy in the same way as the identification of our nearby city galaxies. You can see the axis light from statistical model in its light profiles and Planto in their Peterson ether profiles and Wiley filter in their gamma profiles. Here is inner component and the outer halo and the transitional ellipse. We also studied its stellar population. The top panel is the optical spectroscopy observed by VLT. It shows very weak emission lines indicating the old stellar population. Bottom panels are the SEDs for inner component and outer halo. We derived the specific star forming rate of both components. Extremely low specific star forming rate in both components indicate the passively evolving populations. We also showed this high redshift city galaxy is also located close to the center of a candidate clusters. The velocity dispersion of this candidate cluster is about 80, so which is similar a typical cluster in the nearby universe. Okay, we have shown that this high redshift city galaxy has an extended halo, and is with very old stellar population. We have also shown that city halos may be from major dry mergers. So both indicate that some BCGs enter the dry merger phase at epochs earlier than redshift 1. Okay, so we argue that such high redshift city galaxies are more common than expanded because HUDF region is extremely deep, and the HUDF region only cover about 5 square arcminutes, a very tiny region. So maybe such high redshift city galaxies are more common than expected. So imaging deep rich HUDF of more area are needed to confirm our conjecture. Okay, thanks. Yeah, that's all. Thank you.
Okay, questions? Maybe I'll ask it first.
Okay.
It's not clear to me if you follow your gamma, your d-log, the Petrosian parameter that you take the logarithmic derivative of. Do you see an evolution with redshift?
Yeah, so in 2008, we studied a sample of nearby BCDs, right. But now we are studied a sample of intermediate redshift selected from cosmos field. Right. So this work is in process. So.
But you already have values. Are you able to say that one of your sample is at 0.7, is at redshift at 0.6, 0.7 or so? So if you look at your nearby sample and the more distant intermediate redshift sample, do you see a difference in your gammas?
Yeah, sure.
Right?
I think so, yeah.
Going in one sense. Statistically significant?
We found exactly the evolution of the profiles from redshift 0.8 to the 0.
Right.
So yeah, sure. So yeah, but the cosmos field only have one filter bias I band. So I need to
you need more data.
Yeah,
right.
More data. Okay.
And
okay.
More question. Hold on.
So can one say anything about methodicity in the inner region and the outer region? It's very interesting. You say the methodicity is
I think
that support your scenario. If it's really just the minor accretions, and if there is a methodicity mass relation, well, that's many
I think the
methodicity gradient.
Yeah, sure, exactly. So I talked about this with Yicheng so many times. So we are preparing to study the color gradients and their stellar population gradients from intermediate redshift to the nearby universe. So yeah, sure, exactly, yeah.
Charlie.
Well, I have a related question. Do you have a sense of the average stellar ages?
You mean the stellar ages,
yeah.
Right? I think the color, the stellar population gradients from the inner to the outer may be dominated by methodicity gradients, but we don't know age and But this can dominate the evolution of stellar populations. So I need a large sample to investigate this issue. Yeah, sure.
All right, Aaron, last question.
Okay.
Could you clarify maybe the status of, there was a controversial Nature paper in 2009 from Collins and Collins. They've had several papers where they basically look at redshift to 1 and 1.5 UC-Gs.
Yeah.
And the masses are the same.
Oh, sorry. Yeah. So it's called her?
Collins?
Collins? Oh, yeah.
They had a whole series of papers on this, and the size evolution, the mass evolution, basically the lack of mass evolution of BCGs
Yeah.
from high redshifts today. There's no evolution, which is completely contrary to the theory. Do you know if it's been resolved? Or?
Yeah, I remember they used the data of K-bands data, not HSD data. So you can see the much deep imaging are needed to detect the low surface component. Maybe I suspect their estimate maybe wrong, so I need to check this. So okay.
Just a quick comment on that. My guess is that part of that also has to do with an underestimation of the redshift zero stellar masses of BCGs that come out as long.
Yeah. Okay, good.
Agree with that.
Yeah.
Okay, thank you very much.
Okay, thank you.
Well, thank
Yeah.
you.